What if the storm announces itself not through roaring winds or dark clouds, but through the air pressing against your skin? What if, before the first raindrop falls, you can already feel the weight of the atmosphere, thick, humid, and suffocating? And what if that heavy, hot air you sense hours before a hurricane is not imagination, but the most ancient and reliable warning of them all? For centuries, people living in storm-prone regions have spoken of a peculiar sensation before cyclones. The air feels heavier, breathing seems harder, and sweat clings to the skin in an unusual way. Farmers in the Philippines describe it as ngộp, a stifling atmosphere that makes the body restless. Residents in Florida talk about a sticky heat that arrives just before the sky changes. In the Caribbean, elders recall how the air before a hurricane seemed to trap every breath, as though the world itself were holding still. These descriptions, drawn from lived experience, align with what modern science now explains. The sensations are not superstition. They are rooted in the physics of humidity, temperature, and pressure that govern how storms form and intensify. The National Hurricane Center, NHC, defines humidity in terms of dew point, the temperature at which air becomes saturated with water vapor. As a storm approaches, moisture levels rise dramatically, increasing the dew point. This means the air can no longer absorb sweat efficiently from the skin, making people feel hotter and stickier. At the same time, the storm feeds on this humidity as its energy source. The more moisture in the air, the more latent heat is released into the atmosphere when that vapor condenses into cloud droplets. This process, surface enthalpy flux, is the fuel that powers tropical cyclones. What humans feel as oppressive humidity is, in scientific terms, the storm gathering its strength. NASA's Earth Observing System, EOS, has studied humidity profiles before hurricanes, showing how moisture saturates not just the surface, but extends high into the troposphere. In satellite readings, these profiles appear as towering columns of water vapor, precursors to explosive convection. But to someone standing on the ground, it feels simple and visceral. The air is too wet, too heavy, too hot. The body reacts instinctively, registering the buildup of energy long before instruments confirm it. This is why people often describe the atmosphere as suffocating before landfall. It is not that oxygen levels drop, those remain stable, but that high humidity prevents sweat from evaporating, reducing the body's ability to cool itself. The result is thermal discomfort, a sense that every breath is thick. For those in coastal communities, this sensation has always been a clue. When the air grows oppressive, a storm is near. Another visible clue tied to humidity and heat is the sudden appearance of fog or mist. In normal conditions, fog forms when the air cools to its dew point, causing water vapor to condense. But before a hurricane, the process can occur unexpectedly. As moist, unstable air masses interact with local land surfaces, fog may develop even during warm periods of the day. Fishermen in the Philippines speak of mornings when mist rolled in from the sea, shrouding villages hours before typhoon winds arrived. In Florida, residents have observed unusual hazes that make the horizon blur, even under otherwise bright skies. These microclimates of condensation are products of high humidity, signaling that the atmosphere is saturated and primed for storm development. Historical accounts reinforce these observations. Before the Great Galveston Hurricane of 1900, survivors described days of suffocating heat and humidity. The air was like soup, one resident later recalled, and the sweat would not dry. Similar testimonies come from survivors of Hurricane Katrina in 2005, who remembered the days before landfall as oppressively hot and damp, with the air clinging to their bodies. These subjective experiences mirror the objective science. Hurricanes thrive on latent heat, and before they strike, the air is loaded with it. The heaviness people feel also ties to pressure. As a storm approaches, barometric pressure drops. While humans cannot directly sense pressure changes as instruments do, our bodies perceive indirect effects. Some report headaches, joint pains, or ear discomfort as pressure falls. Combined with high humidity, this creates an overall sense of unease, what many simply call storm feeling. It is the intersection of physics and biology. The atmosphere changes and the human body notices. But why does this matter today, when satellites track storms days in advance? Because in moments when communication fails, human sensation remains one of the most immediate warning systems. Feeling oppressive humidity, noticing unusual fog, or recognizing suffocating heat are clues that nature itself provides. In rural areas with limited infrastructure, these sensations can be life-saving. Even in urban settings, where forecasts are accessible, they add a layer of personal awareness that complements official warnings. The science also underscores how storms and humans are linked through the same processes. The discomfort we feel in our bodies is the same process that powers hurricanes. As water vapor condenses in storm clouds, it releases latent heat, driving convection and intensification. At the surface, that same saturation prevents sweat from cooling us, making us feel overheated. In this sense, the storm's energy is written into our own skin. Case studies highlight how consistent this pattern is across cultures. In Japan, survivors of Typhoon Vera in 1959 recalled unusual warmth and moisture before landfall, describing the air as unbreathable. In the Caribbean, oral traditions teach that when the air feels like boiling water, a hurricane is imminent. In Florida, longtime residents warn newcomers to watch for the sticky stillness before a storm. These cultural narratives, though expressed differently, describe the same physical reality. The sudden presence of fog is especially telling. NASA studies show that moisture levels spike in the lower atmosphere before hurricanes. This saturation makes condensation easier, allowing fog to form unexpectedly. To observers, this may feel like the world closing in, as visibility drops and the air grows damp. Combined with heavy heat, it creates an atmosphere both physically uncomfortable and psychologically unsettling. Survivors often describe these moments as the most eerie, when the world feels wrong, even before winds begin to howl. Misinterpretation of these signals can be dangerous. Some dismiss the oppressive air as simply seasonal heat, or the fog as ordinary morning mist. Yet, during storm season, these changes are rarely accidental. They reflect large-scale atmospheric shifts tied directly to the approaching cyclone. Recognizing them for what they are, warnings, can mean precious hours gained in preparation. The National Hurricane Center's glossary highlights surface enthalpy flux as a core driver of storm intensification. This technical term refers to the exchange of heat and moisture between the ocean and atmosphere. To the scientist, it is a process measured in joules per square meter. To the villager standing on shore, it feels like suffocating humidity and oppressive warmth. The language differs, but the reality is the same. What our bodies perceive as discomfort is in fact the fuel source of the storm itself. The psychology of humidity also plays a role. Studies show that high humidity reduces cognitive performance, increases irritability, and heightens anxiety. Before storms, this contributes to a collective sense of unease. Communities describe restless nights, difficulty sleeping, and tension in the air. These effects, though subtle, reinforce the instinct that something is wrong. The body, the mind, and the environment all align to deliver the same message: prepare. One striking aspect is how universal these signals are. Whether in the tropics of Southeast Asia, the coasts of the Gulf of Mexico, or the islands of the Caribbean, people describe the same sensations: heavy air, sticky heat, unusual mist. Despite differences in culture and language, the warnings are identical because the physics is universal. Storms feed on moisture, and humans sense that moisture in their own discomfort. The conclusion is clear. When the air feels thicker than normal, when sweat clings without drying, when fog arrives at odd times, these are not minor inconveniences. They are signals of a system in motion, a cyclone building its strength. To dismiss them as coincidence is to ignore one of the oldest and most reliable warnings nature offers. Because the truth is simple. Before the storm roars, it breathes, and its breath is heavy, hot, and humid. Imagine stepping outside on the morning before a major hurricane. The winds have not yet arrived. The sky may still show patches of blue between distant clouds. But the moment you inhale, you know something is wrong. The air feels thick, as though every breath carries weight. Sweat collects instantly on your skin but refuses to evaporate. The world seems wrapped in a damp blanket, and an almost invisible haze blurs the horizon. This sensation, described by survivors across generations, is one of the most consistent and haunting precursors to tropical cyclones, the suffocating humidity and heat that signals a storm's approach. NASA's Earth Observing System, EOS, has provided data that helps explain this phenomenon. In the hours and days before hurricane intensification, satellites detect dramatic increases in water vapor throughout the troposphere. Profiles show moisture surging upward, filling layers of the atmosphere that are usually drier. From space, this appears as dense plumes of humidity spreading outward from the developing cyclone. On the ground, it translates into what ordinary people feel as oppressive heat and stickiness. The science and the human experience are describing the same truth in different languages. Case studies confirm the reliability of this clue. Before Hurricane Katrina struck in 2005, residents of New Orleans described the air as swamp-like, unusually heavy even for August. Many remembered difficulty sleeping the night before landfall because the air conditioning seemed powerless against the muggy environment. Meteorologists later confirmed that humidity levels were exceptionally high, fueling Katrina's final burst of intensification over the Gulf. What people experienced as discomfort was, in fact, the storm's energy reservoir building to lethal levels. In the Philippines, survivors of Typhoon Haiyan in 2013 recalled similar sensations. It was like breathing through water, one villager said. Even when standing still, you were drenched in sweat. Farmers noticed fog rolling over their fields during hours of unusual warmth, even though conditions normally would not produce mist. Scientists analyzing Haiyan's approach noted a surge in dew point values across the region, evidence of an atmosphere supercharged with moisture. The body's perception of suffocation was not a metaphor. It was a physiological response to an environment at saturation. Florida residents also recount the same phenomenon. Before Hurricane Andrew in 1992, many remembered days of air so hot and wet it felt unbearable, even by South Florida standards. Newspapers of the time reported that residents described the pre-storm environment as claustrophobic. Again, the science supported the testimony. Surface enthalpy flux from the warm ocean to the atmosphere was unusually high, feeding Andrew's explosive strengthening into a Category 5 monster. The National Hurricane Center, NHC, glossary, highlights dew point as a critical metric in storm development. Dew point is not just another measure of heat, it is a direct indicator of how much water vapor the air holds. When the dew point climbs into the mid-70s Fahrenheit or higher, the air feels intolerably sticky to humans. At the same time, storms see it as perfect fuel. The exact same vapor that prevents sweat from evaporating and cooling our skin is the vapor that condenses in storm clouds, releasing latent heat and driving hurricane intensity. What our bodies register as misery is the storm's feast. The sudden presence of fog before storms deserves further attention. Normally, fog requires cooling air to reach its dew point. But in storm environments, the atmosphere is so saturated that even small changes in surface conditions can trigger condensation. This produces mist in unexpected times and places, early morning fog that lingers past sunrise, hazes in midday heat, or low clouds hugging the ground as winds begin to shift. To coastal residents, these anomalies are striking. Survivors of Hurricane Mitch in Honduras in 1998 spoke of fog banks rolling inland long before heavy rains began. To scientists, this fog is another visual sign of the extraordinary humidity the storm is pulling into its system. Cultural interpretations of this suffocating atmosphere are fascinatingly consistent across the globe. In the Caribbean, elders speak of the breath of the hurricane, describing the air before landfall as thick and alive. In Japan, survivors of Typhoon Vera in 1959 said the air felt as if it could be chewed, a metaphor capturing the density of humidity. In the Philippines, the phrase ngộp conveys the same, a suffocating air that presses on lungs and skin alike. These expressions may differ in language, but they converge on the same lived reality. Long before meteorology existed as a science, cultures had already recognized and named the sensation that precedes a storm. There are psychological effects as well. High humidity is known to reduce human comfort, increase irritability, and cause fatigue. Communities facing hurricanes often recall a restless unease in the hours before landfall, with people pacing, sleeping poorly, and feeling on edge. These effects are not just emotional, they are linked to how the body responds under stress when cooling mechanisms fail. A population already anxious from forecasts now finds its environment physically heightening that anxiety. The storm is not yet visible, but it is already shaping behavior through the air itself. NASA's EOS data further explains why the discomfort is so extreme. Hurricanes thrive on the transfer of heat and moisture from the ocean to the atmosphere. This process, surface enthalpy flux, involves massive exchanges of energy. As warm seawater evaporates, it fills the boundary layer with moisture. Winds then transport this moisture inland, raising dew points and saturating the air far ahead of the storm's center. Humans living in these regions are essentially standing inside the fuel line of the hurricane. They feel what the storm needs most: heat and humidity. Some survivors recall the suffocating atmosphere as more frightening than the winds themselves. In Tacloban, one woman described the hours before Typhoon Haiyan as a nightmare without movement, where the air itself felt threatening. In New Orleans before Katrina, residents spoke of a heavy silence broken only by the sound of cicadas, insects equally affected by the environment. These testimonies highlight that storms are not experienced only through destruction, but also through the oppressive anticipation written into the air. What makes these clues so powerful is their universality. Clouds may look different depending on location, waves may vary depending on the coastline, but humidity and heat are experienced directly by the human body everywhere. You do not need training to notice sweat that will not dry or fog appearing at odd times. You only need awareness that these sensations are not random. They are part of the storm's fingerprint. The danger, as always, lies in dismissal. Some write off oppressive heat as normal for the tropics. Others see fog as seasonal coincidence. Yet during storm season, these changes rarely happen without reason. They are signals embedded in physics, precursors to one of nature's most violent processes. To ignore them is to ignore one of the few warnings accessible to everyone, regardless of education or technology. Emergency managers are beginning to integrate this knowledge into preparedness campaigns. In the Philippines, posters remind villagers that air that suffocates means storm that devastates. In Florida, meteorologists explain dew point and comfort levels during broadcasts, showing how human sensation aligns with storm data. By teaching communities to respect what their bodies already notice, these programs aim to close the gap between science and instinct. This integration is essential because technology, while powerful, is not infallible. Power outages, broken communication lines, or remoteness can sever access to forecasts. In those situations, recognizing the storm in the air may be the only clue left. If you feel the suffocation, if you see the fog, if you notice sweat refusing to dry, the storm is near, even if no forecast reaches you. Awareness of these sensations gives individuals agency when systems fail. The lesson is consistent across time and geography. Oppressive humidity, stifling heat, and sudden fog are not coincidences. They are the body's encounter with the storm's physics. They are nature's way of making us part of the system itself. To feel suffocated is to stand in the same environment that the hurricane is feeding upon. Because before the winds howl, before the surge rises, before the rain falls, the storm is already there. In the air we breathe, in the sweat on our skin, in the heaviness pressing down on our lungs. The discomfort is not separate from the cyclone. It is the cyclone announcing its approach. The weight of the air before a storm is not just a feeling. It is physics, biology, and history colliding at once. Across cultures, people have described it in different words, but the essence remains the same. An atmosphere that presses down, suffocates, and warns. To ignore that sensation is to overlook one of nature's most universal signals. From Florida to the Philippines, from the Caribbean to Japan, communities recognize the same clues. In New Orleans before Hurricane Katrina, residents said the air felt like a swamp, hotter and heavier than usual. In Tacloban, before Typhoon Haiyan, villagers described the atmosphere as unbreathable, as if each lungful of air was waterlogged. In Japan, before Typhoon Vera, survivors recalled the sensation of chewing the air, their way of describing extreme humidity. In the Caribbean, elders spoke of the breath of the hurricane, a phrase passed down through generations to remind people that the storm always arrives before its winds. These testimonies, though varied in expression, point to a shared truth. Human bodies are sensitive barometers, capable of detecting atmospheric shifts that instruments later confirm. Science offers the explanation. The National Hurricane Center glossary, highlights dew point as the critical measure of comfort and storm energy alike. When dew point rises, the air holds extraordinary amounts of water vapor. This not only fuels storm clouds, but also prevents sweat from evaporating, trapping heat in the human body. People feel suffocated because the cooling mechanism of evaporation fails. NASA's Earth observing system adds further detail. Before hurricanes intensify, humidity profiles show a deep saturation of the troposphere. From space, these appear as vertical towers of vapor. On the ground, they manifest as sticky heat, unusual fog, and breathless discomfort. The alignment of science and sensation is precise. Another concept is surface enthalpy flux, the transfer of heat and moisture from the ocean to the air. Hurricanes thrive on this exchange, drawing latent heat from warm seas into their convective engines. The stronger the enthalpy flux, the more rapidly a storm can intensify. For humans, this same flux is experienced as oppressive air, because the environment is literally overloaded with heat and moisture. What meteorologists describe in equations, the body feels as sweat clinging to skin. The discomfort is not random, it is the storm's fuel being gathered. Fog, too, is a critical clue. Normally expected in cool mornings, fog before a storm appears in odd places and times. This happens because the atmosphere is so close to saturation that condensation requires only a nudge. NASA EOS satellites detect these spikes in moisture, but villagers simply notice the haze rolling in from the sea. For them, the sudden mist is both unsettling and prophetic. In many cultures, fog before a storm has been remembered as the world blurring, as though nature itself was warning people to move. These clues are not only scientific, but cultural survival strategies. In Bangladesh, where cyclones have claimed countless lives, communities are taught that unusual heat and humidity mean a storm is coming. In Florida, meteorologists explain dew point in public broadcasts, helping residents connect their discomfort to actual danger. In the Philippines, posters warn that ngộp, the suffocating air, is nature's signal to prepare. By blending traditional knowledge with modern data, communities reinforce awareness. The body's instincts and the satellite's measurements both lead to the same conclusion: the storm is near. Why does oppressive humidity feel so psychologically unsettling? Research shows that high humidity increases irritability, reduces cognitive performance, and elevates stress. Communities waiting for landfall often describe restless nights, tension, and anxiety even before rain arrives. This is not only fear, it is physiology. The environment is pushing human systems to their limits, while simultaneously feeding the storm above. It is a shared stress between people and atmosphere, a moment when biology mirrors meteorology. Historic disasters prove the danger of ignoring these signals. Before the Great Galveston Hurricane of 1900, survivors remembered air so hot and wet it was like soup. Many mistook it for a seasonal extreme, not realizing it signaled the storm's intensification. When the cyclone struck, the city was unprepared, and thousands died. More than a century later, in Hurricane Maria's approach to Puerto Rico in 2017, residents again described suffocating humidity in the days prior. Meteorologists confirmed that dew points had reached extreme levels, fueling Maria's devastating winds. The stories repeat: the body feels what the storm builds, but unless that signal is respected, tragedy follows. The lesson is urgent as climate change reshapes storms. Warmer seas mean higher enthalpy flux, more moisture in the air, and more intense hurricanes. This also means the suffocating atmosphere people feel before landfall may become more pronounced. Communities must learn to interpret that discomfort not as an inconvenience, but as a warning. The heavier the air, the more energy the storm carries. The hotter the humidity feels, the stronger the cyclone may become. So what should people do when they feel these clues? First, recognize them as signals. Unusual humidity, breathless heat, and fog out of place are not coincidences. Second, contextualize them. During storm season, especially when forecasts already mention threats, these sensations should be treated as confirmation. Third, act on them. Secure homes, check evacuation routes, and prepare supplies. The body's discomfort may be the final nudge to take warnings seriously. Because storms are not silent, they announce themselves through the weight of the air, the stickiness of skin, the haze on the horizon. To those who listen, the message is clear. To those who dismiss it, the cost can be fatal. The conclusion is both simple and profound. The suffocating air before a hurricane is not your imagination. It is the storm breathing, pulling energy from the sea, filling the sky with vapor and pressing that load onto your body. The storm is already here, long before the first winds arrive. At Crisis Lens, we believe awareness is survival. The clues are around us, in the tides, in the clouds, in the air itself. By learning to read them, we transform fear into preparedness. When the air grows heavy and the world feels harder to breathe, do not dismiss it. That is the storm's signature written into the atmosphere, urging you to act. Subscribe to Crisis Lens for more deep dive explorations into the hidden warnings of nature, the science behind disasters, and the survival lessons we all need in an age of intensifying storms. Share this video with those who live in storm-prone areas and turn on notifications so you never miss a signal. Because when the air itself begins to change, the clock has already started.